Okay, chapter 5, lesson 6, day 1. Here we go. We're going to do some square root work again. So let's just have a little recapper on how to break these things down. You got 5 root 2, yeah, right there. Let me change that color. Over here, you would want to break down square root 3, square root a, square root 4, square root 3, square root h, square root 2, square root h. And now I'm going to put some stuff together. I'm going to have a 4, which is a 2. I got these two 3's, makes me a 3. I got these two h's, makes me an h. And I got an a and a 2 that are still left underneath the radical. Square root of a, square root of 2. So my answer, 6h, 6h, square root 2a. And that's it. That's it. Square root 7, square root 5, square root 5, square root 3. These two come out. These two get put back together, and we're done. Difference between squaring a normal one here, squaring a normal one. Let's try blue. Square the first term, 4x squared, multiply them together and double it, 12x. Square the last term, 9er. You square a square root, you're set free. That's it. Set me free. Just got to remember some stuff about some quadratics back in the day. If we're going to solve by factoring, the first thing I'm going to do is I'm going to move the 9 over. And then I'm going to factor. What do you multiply for 14? Add for negative 9. Going to probably be negative 7 and negative 2. Set them both equal to 0 and solve. Look at how easy those are now. Look at how fast they go. We're so good at those now. It's just excellent. Square root property. When they ask you to use the square root property, that means this is a perfect square. Remember, sometimes they're already set up. What do you square to get x squared? X. What do you square to get 1? 1. Does it check out that we square the first term, multiply them together and double it, square the last term? It does. And just like that, we are ready. Square root both sides. X plus 1 is plus or minus 4. Big thing here, you got to remember. There's two problems. X plus 1 equals 4. X plus 1 equals negative 4. Subtract 1. Subtract 1. We are good. Two answers. No big deal. Over here now, we've got an object is dropped from an unknown height and reaches the ground in 5 seconds. That's a time, 5 seconds. Use this equation where t is the time, h is the height, to find the height. So I'm going to say 5 equals the square root of h over 4. Well, the first thing we're going to do is square both sides. And that sets it free. And then we multiply by 4, and look at that. We were 100 feet high when we dropped our object. Hopefully it didn't hit anybody in the head. Okay, we're going to solve radical equations. You've done this before, but again, like most things, you kind of put an extra step in here or there. Isolate the radical. That means to get it by itself. Raise each side to the power of the index. So if it's a cube root, you got to cube both sides. If it's a square root, you square both sides, and so on and so forth. And then you solve after that. Okay, so here we go. Here we go. First thing we're going to do, you must isolate. You can't just square right now. You have to get the radical by itself. You have to add 1 to both sides. If you don't do that, you're going to throw the whole kit and caboodle out the door. It's going to be no good. Okay, so now I've got this by itself. This is the index is 2. We're taking the square root. We square the square root so it gets set free. and I get 121 minus 3 minus 3. 2x is 118. Divide by 2. Divide by 2. X must be 59. 59. You do need to check. I know sometimes we kind of scoff at checking. You got to check these ones because we got to remember you're not allowed to take the square root of a negative. There's going to be some things that are going to get thrown off here if you're not careful. 59 times 2, 118 plus 3 is going to be 121. Square root of 121 minus 1 is that 10 is 11 minus 1, 10. It is. We are good. Check to the winner. Okay, same idea here. So we're going to go, I'm going to change the pen color. Let's try cyan, see what that looks like. Oh, you probably can't even see that. Let's change that again. So the first thing we're going to do is we're going to, whoa. We're going to magenta. Ooh, like that. Isolate the radical. This is going to be a 6. Square both sides. Y minus 2 is 36. Add 2. Add 2. Piece of cake. Upside down. 38 minus 2 is 36. Square root is 6 minus 1. We are good. Ciao. Okay. Good deal. Good deal. Check your... Sometimes they're already ready to go, huh? Square both sides. X minus 12 is 4. X is 16. Check it out. Plug it in. We are fine. Okay, so I would say at this point, you're probably thinking, well, what's the catch? Well, we've got no catch to this juncture. This one's going to be the same idea. Square root of x minus 3 is 8. Square both sides. X minus 3 is 64. Add 3x is 67. Check it out. 67 minus 364. Square root 8 minus 2. And we're fine. We're fine. Okay, if you were punched out, you should punch back in because now things are about to get real. Things are about to get raw. Sometimes they're going to be real raw. Here we go. Isolate the square radical, and I get this, right? And now take a look at what we've got going on here. What's going to happen when I square both sides? Ooh, doggy. I got to square both sides. And now we got to remember how to square a binomial. Squaring a binomial. When am I ever going to use this in my life? X squared. Multiply the two terms together and double it. Oh, that's when we're going to use something like that. Oh, isn't that great? Minus 2 minus 2 minus x minus x. So all those skills that paid the bills in Chapter 4, they're coming back around to haunt us. Hey, we already saw this problem. If you were paying attention at the beginning, don't all raise your hand at once, it was minus 7 and minus 2. So I quickly get x equals 7 and x equals 2. Stop right there because we have got to go check our work. Because if I'm going to go, the square root of 7 plus 2 is 9er, right? Plus 4 is that equal to 7, and I get 3 plus 4 is 7. So right there, this checks out. That's good. Got to check the other one, though. Square root of 2 plus 2 is 4, plus 4 is 2. Ruh-roh, we got a problem, people. Is 2 plus 4 equal to 2? It is not. This one fails. That's an extraneous root or an extraneous solutions. Roots that do not make the equation 2. So what happened here was when we square both sides, the domain of what's underneath here really kind of comes into play. And that's why we got to check our work there. We got to check your work. Okay, that was a good one. Okay, when suddenly we drift on back to a normal problem, yeah, we just minus 7, square root of 3x plus 2 is negative 4. Wait a second here. The square root, you can only take square roots of positive numbers. Oh dear, that means the square root of 3x plus 2, that's the square root of a positive number, is equal to a negative. When is a square root going to be equal to a negative? Oh wait, how can I take the square root of a positive number and get a negative? I can't. This is going to be no solution. What if I didn't recognize that? What if? What if I didn't recognize that and I squared both sides? 3x plus 2 is 16. 3x is 14. X is 14 thirds. Yuck. Notice I get x is 14 thirds, but if when I plug it in, if I check my work, then I get the square root of 14 thirds times 3. That's 14 plus 2, that's 16. Look at. When you check your work, you get something that is not true. Is 11 equal to 3? It is not, and therefore this is no good. Since there's no answer, it's no solution. No solution. That's going to be very important. There is an issue. It calls for the principal square root that is not 0 or positive, therefore no solution. Yeah, so you can recognize it right away, but sometimes you don't see it, and that's why checking your work saves you. Inequalities greater than or less than. If the index of the root is even, identify the values of the variable for which the radicand is non-negative. Solve the inequality algebraically. Test your solution. Okay, here's the deal. You can't take the square root of a negative, and therefore, well, you can't take the even root of any negative. You can take the odd root of anything you want. No big deal. So what you got to watch out for here is when, after you isolate the radical, minus 4, the square root of 3x minus 6 is less than or equal to 3. Right here, what you got to remember is, yeah, you can be less than 3, but whatever is underneath here, okay, whatever we're taking the root of, that radicand, has to be greater than 0. So you have to extract. I like to extract, just like you're extracting a tooth. I like to extract this and say, hey, I have got to check the domain here. This has got to be greater than or equal to 0, because we're not allowed to go into negative land. So I add 6 over, and I divide by 3, and I say the lowest x can go is 2. X has to be greater than 2. And then I go up here, and I square both sides, and I solve the rest of it the normal way. 3x minus 6 is less than or equal to 9. 3x is less than or equal to 15. And x is less than or equal to 5. So take a look at what we have here. I have to have values that are greater than or equal to 2, less than or equal to 5. So we can write that x is greater than or equal to 2, less than or equal to 5. That would be my domain. My domain would be from 2 to 5. Those are all of the values that would make this work. Pick one that's in there. Okay, 4. 4 times 3 is 12 minus 6. I get the square root of 6. Square root of 6 is like 2.3. 2.3 plus 4 is less than 7. Yes, it works. But you got to notice, if I went further, if I put 0 in there, how come we had to do this now? If x can't be 0, if I put 0 in here, 0 minus 6 is negative 6. The square root of negative 6 is an I, imaginary. So we have to put a stop up. Okay? So you're going to want to watch out. After you isolate the square root, you need to make sure if it's a less than, I have to stop at 0. Okay? Now, if it's a greater than, no big deal. You can go greater than forever as long as it's greater than a positive number. Good stuff. There you go. The domain values, that's like that 2 to 5 that I was just talking about. There's your homework. Have a great time. It's been real.